Electrolysis can be described as a process by which electric current flowing through a liquid causes a chemical change. Yes, it is as simple as that. Please note that not all liquids can conduct electric current. The electrolyte can be a molten ionic compound or an aqueous solution. In either case, it must be able to carry current. For the purpose of this practical demonstration, we will be using the typical table salt, sodium chloride. This electrolysis setup comprises of a beaker, electrolytic tank, electrode, ammeter, switch, water, substance in molten form, and bottles. First, let's start by pouring the sodium chloride into the tank. The sodium chloride is poured into a bowl containing water. The water serves as our electrolyte. Next is to connect the bottles. The mixture will contain free-flowing positive sodium ions and negative chloride ions. Positively charged ions are called cations, while the negatively charged ions are called anions. There are two electric conductors placed inside the electrolyte. These conductors are copper because copper has a high melting point, so it's good for conducting electric current. The electric conductors are also referred to as electrodes. Nothing happens to the ions at this point, but if connect a 2 bit of copper to an electrical cell or a power supply, things start getting interesting. Now, let's plug the ammeter and switch on the power button. As you switch on the power button, the ions start moving in the direction of the opposite charge. The electrons will start to flow on the wire, and this would cause one electrode to be positively charged and the other negatively charged. This has an immediate effect on our sodium chloride, which, if you can remember, is a mixture of sodium cations and chloride anions. When the ions meet the electrode, electron exchanges take place, which eventually triggers a chemical reaction. Gases are given out, namely hydrogen gas at the anode and chlorine gas at the cathode. The liquid is now effectively conducting electrical current. Remember that electrolysis can also take place in molten substances as in ionic solutions. The more concentrated the solution, the greater the ion flow rate. The ion flow rate can also be increased by increasing the potential difference or voltage across the cell. In order to collect the gases, two bottles with hoses are connected to the top of the bowl. The bowl will also have two holes that allow the gas to pass through it. Right inside the electrolysis tank, we see that the gas passes through the water into the balloon. At the end of the reaction, we observe that the bigger balloon contains the hydrogen gas, which was displaced more rapidly than the smaller balloon containing the chlorine gas.